Let's go to Asanda and see what sort of question they have for us.
Hey Nikita, what's happening?
Nothing
Nothing much. Okay, so just tell me, like, when you guys are having fun, like, what's your favorite thing to do?
I like to play computers a lot, swim, yeah.
Okay, and do you like? Okay, I guess like swimming would be one of your hobbies.
Yes.
Okay, and what else?
Well, that's about all. I like to read books a lot too.
Okay, so what are you reading at the moment?
Kathy Hopkins.
Oh, nice choice. Okay, you go ahead and you ask your question, and we'll chat more about the books.
What practical evidence of magnetic forces do we have?
Well, let's see if they can tell us.
So what practical evidence do we have for magnetism, for the existence of a magnet? Now, I think in a way we started answering that question when we first started looking at magnets and how they behave. But let's go and play around a little more, because the one thing about magnets is they're wonderful to play with. Here I have a piece of magnetic material. Now, I know it's magnetic, but you don't. How can I prove to you that it is? Well, as we know, we can take magnetic materials and we can see how they're affected. What have I got here? I've got coins. I always thought that coins weren't magnetic, but clearly our coins are. There's an interesting thing happening here. These coins are rushing off to the edge. I wonder why that is. Maybe we could investigate that a little more. These are paper clips, big ones, small ones. This is a little resistor, an electronic resistor. Now, the central part of the resistor isn't affected much, but of course these are leads, metal leads, and they are affected. Here I have a nail, as we might expect. A nail is certainly going to be affected. It is a steel nail. And here I've got bits and pieces of material that give us evidence of, or practical evidence, that there are magnetic forces involved. In the next activity, you're going to apply your knowledge of magnetism and magnetic materials and see what you can come up with. Well, I hope that went well. Now let's see what Asanda and her helpers have with their final question.
So now what's up?
Nothing much.
You just good?
Yeah, I'm fine.
Okay, so tell me a bit about yourself, and I want to know what hobbies you get up to.
I do dancing and beading.
Okay, and what other things do you like?
Pretty much just watching TV and lazing around, being lazy.
What's your favorite TV program?
Grey's Anatomy.
Oh.
It's not on at the moment, so I have to do with army wives.
Okay, cool. You go ahead and ask your question.
Are magnetic forces different from other forces?
Well, let's see.
That's an interesting question. Are magnetic forces different to other forces, or different from other forces? Well, forces. What do we know about them? Let's collect some of our evidence and see if there is something distinctive about the magnetic force that doesn't apply to the others. Still, one of the best definitions of forces would be the first definition you ever learned is that a force is a push or a pull. Because the big thing about a force is that we know forces are acting when we see the effects of the force. And when you see something moving or something stopping or something starting, then we know that a force is acting. And we can't always see what is causing the force. But a force causes some kind of push or pull, and it causes an effect. And the nature of the effect is going to depend on the kind of force that we're talking about. We can also talk about attractive and, is it and or is it or? Repulsive forces. When things are attracted together or when things are repelled. We also know something interesting from our discussion of forces is that they always act in pairs. So in other words, if you, or remember my little angel, standing on the earth, there's the angel with her little wings, the angel is attracted, use a different color here, towards the earth. And surprising as it may seem, the earth is attracted towards the angel as well. Although the size of the mass of the earth means that that little force is not going to be noticed by the earth as much as it is noticed by the angel being drawn towards the earth, so that when the angel jumps, the angel falls back to earth because of the force of gravity. But the force of gravity is always this pair that happens between the two bodies that are attracting one another, equal in size and opposite in direction. So we always get pairs of forces. Now, what do we notice with magnetic forces? Well, yes, we've seen pushes and pulls, and in fact we described those pushes as repelling and the pulls as attractive when we brought these two magnets together. So certainly those apply to magnetic forces. The effect, well, it causes movement. We saw that when one magnet was brought close to another, it caused that other magnet to move, either attractive, pull them together, in the case of my large magnets, very, very quickly, or it forced them apart, but it caused movement. Did they act in pairs? Well, I think we can reason out for ourselves that when we brought our two magnets close together, if I were to push both magnets at the same time so that they get to within the distance where the magnetic force is actually operating, the repulsive force, or if they're turned around so that they have like poles, let's say if you've got a north and a north pole, we've got a repulsion. When you push these two things together, I'm going to feel the repulsive force on both of my fingers. In other words, there is a force acting back on this one and back on that one. And so I can certainly say that when I bring two magnets close together, the forces of repulsion there are forces of repulsion. There is a pair at least which is acting on both of the magnets that are brought close together. So yes, it certainly seems that they act in pairs.